Hi guys, just as a heads up, if you can read the directions here, it says graph each function without using a calculator. You'll need to make a table and show your work. These are tricky. Please take your time and don't give up. So please take your time. Just as a heads up, this video will probably be a little bit longer than they normally are. Last week together we completed a Desmos activity. If you haven't quite done that yet, please go back and complete that Desmos activity from last week, as that's part of your assignment and part of your notes. So for this week, I just want to sort of recap with you about graphing sine and cosine with these shifts. The process is the same for graphing sine and cosine, so I'll do a few examples here with graphing sine. So the first thing that we want to do is we want to sort of take a look here and analyze this function that we're trying to graph. So to come back and make some notes here, the amplitude I know is the absolute value of that a value, which in this case is going to be 3. The period is 2 pi over b. So in this case, my period will be 2 pi over 1/2, which is going to give me 4 pi. We'll talk a little bit more about this key point scale, but this is just going to tell us sort of what nice increments to go up by each time, and we'll do this by taking my period and cutting it in 4 chunks. So 4 pi divided by 4 is going to be pi. My phase shift here is negative c over b. So when we're talking about that a sine of bx minus c plus d, my phase shift here is negative c over b. Since there is no c value, my phase shift is just 0. And my phase shift gives me important information about where my table should start. So if I'm sort of picking up my function and shifting it from left to right, I still want to graph some pretty nice values here. So I know that my table will start at 0. And my vertical shift, this would be if there was a d value, and there isn't any d value here. So what I want to go ahead and do is I want to make a table, and I want to plot 5 key points. And my phase shift here is telling me where I should start my table, so I'm starting it at 0. And my key point scale here, so this guy right here, is telling me what I should increase my table by each time. So I'm going to go up to pi, so I'm going to add pi each time. So 2 pi, 3 pi, 4 pi. So I have 1, 2, 3, 4, 5 points. That will give me a really nice I'll graph an entire period with these 5 points. So I'm starting at 0, and let's label my graph using my increments. So pi, 2 pi, 3 pi, 4 pi, and let's just go up to 5 pi here to fill it out. Over here I'd have negative pi, negative 2 pi, negative 3 pi, and so on and so forth. So now what I want to do is I just want to fill in. So f of 0 is 3 sine of 1/2 times 0. It's going to give me 3 times sine of 0, which is just going to output a 0 for me. So f of pi, 3 times sine of 1/2 times pi, which is going to give me 3 times sine of pi over 2. So sine of pi over 2 is 1, and 1 times 3 is 3. I'm just going to erase this to give myself a little bit more space. So now I'll do f of 2 pi, which will be 3 times sine of 1/2 times 2 pi. It's going to give me 3 times sine of pi, which again is going to be 0, and 3 times 0 is 0. F of 3 pi is going to give me 3 times sine 1/2 times 3 pi. So 3 sine of 3 pi over 2, which is going to give me this piece right here will give me -1. So that's going to overall give me -3. And if I plug in 4 pi, I'm back where I started at 0, or 2 pi, the full rotation. So I know I'm back here at 0. So here is my 3 and -3. So I'm here at 0, 0, over pi and up 3, 2 pi, I'm at 0, 3 pi, I'm at -3, and 4 pi, I'm back at 0. So I can just come in and sketch a really nice period of this sine function here. So again, it is a little bit of work. Remember that you have the ability to pause, stop, rewind, fast forward this video. And I encourage you to do so. But why don't we do another example together so that we can really get the hang of this. So let's take a look down here at this example. So my amplitude is the absolute value of A, which is going to be 1 since my A value is -1. My period is 2 pi over B, and it looks like B is 1 in this case. So my period is 2 pi. My key point scale, I'm going to take my period and divide it by 4. So 2 pi divided by 4 is going to give me pi over 2 as my key point scale. My phase shift is -c over B. So my phase shift here will be -pi over 1. So -pi. And again, this is telling me where my table should start. And here there's no vertical shift, so there's no D value, so we'll leave that out. So I'm starting at -pi, and I'm increasing by pi over 2 each time. So -pi over 2, plus pi over 2 gives me 0, plus pi over 2 gives me pi over 2, plus pi over 2 is going to go ahead and give me pi. So now I can work on filling in my graph here and filling in my table. So let's go ahead and let's call this pi over 2 and pi, and 3 pi over 2, 2 pi. We'll call this -pi over 2 and -pi. So now I can go ahead and fill in my table. So I'll have f of -pi is going to give me -sine of -pi plus pi, which is -sine of 0. So sine of 0 is 0, and -1 times 0 is going to give me 0. F of -pi over 2 is going to give me -sine -pi over 2 plus, let's call it 2 pi over 2 for a common denominator. So this gives me -sine 2 pi over 2 minus pi over 2, or -pi over 2 plus pi over 2 is just going to give me pi over 2. And at pi over 2, I'm at +1, so let's multiply by this negative right here. So I'm here at -1. And let's erase this. I'll just do a few more. So here I have f of 0. So -sine of 0 plus pi. So -sine of pi. Sine of pi is going to be 0, and -1 times 0, again, I'm at 0. And f of pi over 2 is -sine pi over 2 plus 2 pi over 2. So -sine of, that's going to give me 3 pi over 2. And at 3 pi over 2, I am at -1. So -1 times -1 will put me here at +1. And then I'll be back here at sine of 2 pi, which is going to give me 0. And I say 2 pi because once I plug pi in for here, I'll have sine of 2 pi. So at -pi, let's graph this in a different color. I'm at 0. And at -pi over 2, let's call this -1, and let's call this +1. I'm down here at -1. And at 0, I'm at 0. And at pi over 2, I'm at +1. And at pi, I'm back here at 0. So again, This looks a little bit different because I have a negative sign, which is why my sine graph is reflected. And this is my shift. I picked up my graph and I shifted it over by pi. So there's a really nice example for that. Let's do one more example together, which I have here. So my amplitude is the absolute value of A. So my amplitude will be 4. So I know 1, 2, 3. I'll label this as 4. 1, 2, 3, 4. And down here at -4. My period is 2 pi over B, which is just going to be 2 pi because my B value here is just 1. My key point scale is my period divided by 4. So 2 pi divided by 4. It's going to give me pi over 2. My phase shift is going to be negative C over B. So negative pi over 1. So my phase shift is going to be at pi. And there's no D value here, so I don't have any kind of vertical shift. So let's go ahead and start making my table. So here I have my X's and Y's. So my phase shift is telling me to start my table at pi, and I'm going to increase by increments of pi over 2, which is my key point scale. So I'll then go to 3 pi over 2 and 2 pi and 5 pi over 2 and 3 pi. So I can start plugging in values for this. So f of pi is going to give me 4 times sine of pi minus pi. And notice how when we fill in these values, the very first sort of piece that we end up getting here should always simplify what's in your parentheses to 0. And that's why we use our phase shift to help us start our table, so we can figure out where we should be starting and where sort of my parent function graph would be starting. So 4 times sine of 0, this is just going to put me at 0. F of 3 pi over 2 is going to be 4 sine of 3 pi over 2 minus, we'll rewrite pi as 2 pi over 2. So that's going to say 4 times sine of pi over 2, which is going to put me at 4, because sine of pi over 2 is just 1. 1 times 4 is 4. So if you continue to fill this out, we'll get 0, -4, and back at 0. So let's call this pi over 2. We'll call this pi. We'll call this 3 pi over 2. We'll call this 2 pi, 5 pi over 2, and 3 pi. So here at pi, I'm at 0. At 3 pi over 2, I'm up here at 4. At 2 pi, I'm back at 0. 5 pi over 2 down at -4. 3 pi again at 0. And we could continue this if we wanted to, right? We know the trend of what would happen here. Here I would be at pi over 2. Here I would be at 0. And we could just keep going to continue graphing. But I do know that a period of this function exists between, what was my starting value here? Exists between here, this pi, and this 3 pi over 2. So that's a nice period of this function here. So cosine acts the same way. You'll follow the same exact steps. The only thing that will be different is, of course, when you're plugging in over here and filling in your table. So I encourage you to work through some of those problems that are in the homework and make sure that you're following these steps. Specifically, what I'm looking to see here is this table that you're creating. So good luck, guys. There are a few more problems in this problem set if you would like to work on them before you take a look at your homework. But other than that, good luck with graphing without a calculator. And feel free to use Desmos to check your work, not to actually graph here, but to check your work.